Good morning, everyone. So what I want you to start by doing is to simplify these square roots that you see on the screen with a partner. So go ahead and pause the video and simplify these on the back of your packet. All right, I'm going to jump right in. So the square root of 4 we know is 2. The square root of 81 is 9. And we know these things because 2 times 2, there we go, my marker wasn't working. 2 times 2 gets me 4. Just like 9 times 9 gets me back to the 81. So we take that square root, we're looking for that number that when I multiply by itself, it gives me what's under that square root. Now, what about the square root of 2 squared? Well, I know 2 squared is 4, but if you think about it, when I write it this way, I'm taking the square root of something that's being squared. So the square root and the squared undo each other. So I'm just left with that 2. So the square root of 3 squared is just going to be 3. So 5, I have a multiplication symbol here. So I could figure out that 4 times 9 is 36, and the square root of 36 is 6. But because it's multiplication, I can do the square root of 2 squared, which is 2, and the square root of 3 squared, which is 3. And when I multiply them together, I get 6 as well. Now for number 6, you probably started to have a little bit of questions on this one. There's still multiplication here, but the square root of 5 squared is 5, and I can't do the square root of 3. So my answer is actually going to be 5 radical 3. The 3 is not a perfect square, so it has to stay in the radical. Now for 7, you probably weren't sure how to do this. But if we think about 18, if we can break 18 down into some perfect square factors, then we can what's called simplify the radical, and that's what we're doing today. So let's see, 18, I can break that down into its prime factorization. Let's see, I got 9 times 2. 2 is a prime number, and 9 is 3 times 3. So that means the square root of 18 is the same thing as 3 squared times 2. So I can take the square root of 3 squared, that gives me 3, and the 2 is still under the radical. And that's the majority of what this unit is about, simplifying these radicals. All right, so as I just said, this new unit is all about simplifying radicals and working with radicals. So here we have a little bit of notes to read. Our first day is just simplifying them. So radical expressions like 2 radical 3 and radical x plus 3 contain a radical. You read radical x plus 3 one way as the square root of the quantity of x plus 3. You can also read it the way I read it. You can simplify a radical expression by removing perfect square factors from the radicand. Recall that the radicand is the quantity or expression under the radical sign. So this would be the radicand, this is the radicand. All right, so multiplication, this is going to help us with the simplifying. For every number a is greater than 0 and for b greater than or equal to 0, the square root of a times b is equal to the square root of a times the square root of b. So for example, radical 54 can be written as radical 9 times radical 6. Anytime we have a perfect square, so radical 9 is the same thing as radical 3 squared, I can simplify that to be 3 radical 6. All right, so let's try this. So our first example here is radical 50. We're going to take 50 and we're going to break it down into its prime factorization. So I have 50. 50 can be broken down into 25 times 2, perfect square, and then I have 5 times 5. So radical 50 is the same as 5 squared times 2. Only perfect squares can come out of the radical. So out comes this 5. To keep myself organized, I like to put the 5 up top just to remind myself that's what's coming out of the radical. So my final answer will be 5 radical 2. The radical 2 or the 2 has to stay under the radical because it's not a perfect square. Next. Now this one's a little different because I have that -5 in front, but just leave it alone for now. Start with the 300 and do the prime factorization. So let's say I've got 100 times 3, perfect square. Maybe I can do 50 times 2, or I meant prime, not perfect square. And then 50 I can break down into 25 times 2, another prime, and then 5 times 5. All right, so I have that -5 out in front, and I'm taking the square root of, I've got a 3, I've got 2 squared, because there's 2 of them, and I've got 5 squared. So that -5 is out in front, and I'm going to be able to take out a 2 and a 5. These are going to be multiplied, and then we're going to multiply them with that -5 in front. So I have 10 here times -5 is -50, radical 3. So the number in front is being multiplied, it's just that last step that I'm going to do. All right, radical 18. So we can break down 18 into 3 times 6. And then 6 I can break down into 3 times 2. So radical 18 becomes radical 3 squared times 2. So out can come a 3. So 3 radical 2. Notice with that radical 18, that was the same problem I did on the warm-up here, but I decided to go 9 times 2 first. It doesn't matter. You're still going to get down to that same prime factorization. We still got 3 radical 2 for our answer. All right, so what I'd like you to do now is I'd like you to try some of these. I'm going to work through and do them, but pause the video and try these on your own. So 32, 16 times 2. 16 I can break down into 4 times 4, which is 2 times 2, and 2 times 2. So I've got 2 squared, 2 squared, 2. So out of the radical comes a 2 and a 2. So 4 radical 2. All right, 147. So we got 3 and 49. This will be 7 times 7. So I have the square root of 7 squared times 3. So out comes a 7. So this is 7 radical 3. All right, 27. We can break that down to 3 times 9, which is 3 times 3. So I've got 3 times 3 squared. I know that's the same as 3 cubed, but I want to make sure I have 3 squared so that I can show a 3 coming out. So 3 radical 3. Let's see, 200. I'm going to break down into 100 times 2. And then maybe 10 times 10. And then 5 times 2. And 5 times 2. So when I do my square root here, I've got 5 squared. There's 2 5s. And then I've got 2 to the third, but I'm going to write squared and then times 2. So out comes a 5, out comes a 2. So 10 radical 2. 80. Let's see, that's 16 times 5, which is 4 times 4, which is 2 times 2, and then 2 times 2 again. So that's the square root of 5 times 2 squared times 2 squared. So 5, oops. So 2 times 2 is 4, and then radical 5. And then 120. Let's break that down into 10 times 12. And then 3 times 4. And then 10 can be broken down into 2 times 5. All right, so let's see what I have. I've got a 2 squared, I've got a 3, I've got a 5, and I've got a 2. So looking at this, I can see the 2 comes out, but the 3, 5, and 2 here all stay together under the radical, so I'm going to multiply them back. So I've got 15 times 2, which is 30. So whatever's left under the radical, if it's more than one number, just multiply it back. All right, you're going to have lots of practice on that with the homework. But the next thing I wanted to show you is that division works in a similar way. As long as you have both numbers under the radical, you can divide them. So radical 256 divided by radical 32 is the same as the square root of 256 over 32. And when I divide those, I get radical 8. But now we have to make sure we simplify, and that's what we just did. So if I take 8 and I break it down, I get 4 times 2, and then 2 times 2. So I have 2 squared times 2, which is 2 radical 2. So radical 65 divided by radical 13, when I divide, that will be radical 5. And then radical 96 divided by radical 12, that would be radical 8. So I'm just dividing the 96 by the 12, and putting that radical on top. So radical 8, as we just said, was 2 radical 2. So those are division. So once again, you'll have some time to practice those on your homework. All right, the last thing I wanted to go through with you today is something called rationalizing the denominator. So sometimes the radicand in the denominator of a radical expression is not a perfect square. So we need to change the denominator into a rational number. And this is considered to be more simplified. So looking at this example here at A, I have 2 over radical 5. This radical 5 down here is making this expression not simplified. So what we need to do to get rid of this radical 5 down here is we're going to multiply by 1. Radical 5 over radical 5. This has a value right here of 1. That whole thing equals 1. But by choosing radical 5 over radical 5, when I multiply radical 5 times itself, I get 5. Now, you can say radical 25 first, but our hope is that we'll understand that radical 5 times radical 5 is 5. But if you would like to say radical 25 first, that's fine. And then in the numerator, 2 times radical 5 is 2 radical 5. So my final answer is 2 radical 5 over 5. And that is considered to be the most simplest form of the original 2 over radical 5. All right, so I've got 3 of these for us to try. So we have 2 over radical 6. The problem is this radical 6. I can't have it in the denominator. So I need to change it so it's not in the denominator. So I'm going to multiply by 1, except I'm not actually going to put a 1 there. I'm going to do radical 6 over radical 6. The reason I picked that is because I know that radical 6 times radical 6 is 6, because it'd be radical 36. And then 2 times radical 6 is 2 radical 6. Now I'm almost done. I just have to look for anything I can simplify. So I'm only allowed to divide numbers that are not in the radical by each other or numbers that are in the radical by each other. So I can divide out the 2 over 6 if there's a common factor, which there is. They both are divisible by 2. So 2 goes into 2 once, and 2 goes into 6 3 times. So my final answer is radical 6 over 3. I can't divide the radical 6 by 3 because the radical 6 is under the radical and the 3 is not. So I am done. All right, the next one. Think about why this is a problem. I can't have radical 7 in the denominator. So I'm going to multiply by 1. my 1 is going to be radical 7 over radical 7. So that's 8 radical 7. And then what's radical 7 times radical 7? Hopefully you're thinking 7. Is there anything else I can simplify? Hopefully you said no, so we're done. All right, why don't you pause and try this last one? I'm going to jump into it. We're going to multiply by radical 2 over radical 2. So 5 radical 2 over 2. Can I simplify anything? Think to yourself, why can't I simplify radical 2 and 2? Hopefully you're saying it's because one's under the radical and one is not. So I am done. All right, so make sure you try that homework on Delta Math, and I'll see you soon. Bye, everyone.